Welcome back. We're in lesson 56. We're in section A. We're going to talk about triangular areas. And we already know how to find the area of a triangle. We know that the area of a triangle is equal to the base times the height divided by 2. What if we don't have one of those dimensions? This is how we can use sine, cosine, or tangent to find the area of a triangle. So let's just jump into example 56.1 and let me explain how that works. So here is a triangle and we need to find the area of this triangle. Problem is, it's obvious this triangle is not an isosceles triangle. This side is obviously longer than this side, and this base, because it's not an isosceles triangle, we can't draw a line and find halfway. So we're not able to get the dimensions that we need just by looking at this the way it is. But we can use our trigonometric functions in order to find the height of our triangle. And we're going to do that by drawing an imaginary line. An is the correct grammar, by the way. And it's at a 90-degree angle here, perpendicular to the base. So now we have a triangle, a right triangle with a degree angle of 42 degrees. And the opposite angle is going to be our height of our triangle. So we are going to use this 42 degrees and we are going to use sine to find that height. So the sine of 42 degrees is equal to h, which is the height here, over the hypotenuse, which is 12. So that would be 12 times the sine of 42 degrees is equal to our h, or our height of our triangle. So it's the same thing we've been doing with our finding our r's and our u's and our i's and our j's. It's just now we're going to use it to find area instead. So when we do the calculation, 12 times the sine of 42 degrees, we find out that 8.03 is equal to our height right here. I'm going to make that a capital H too, just so there's continuity. So 8.03 is the height of our triangle. Now I can find the area of this triangle. I can say 8.03 times 16 divided by 2. So that would be 64.24 inches square. That would be the area of that triangle. Not difficult when you wrap your head around it. We're just using the same thing we've been using before to find the opposite side, the length of the or the height of the opposite side, whatever that length is. And then we're height times the base. That's all we're doing. Easy peasy. You guys can do this in your sleep. Let's see if we have another practice problem for this. Yes, we do. Let's try another one. All right, so we need to find the area of this triangle, but we don't have the same shape and we don't have the base here. We don't have a height for this base to calculate it. So we got to think outside of the box just a little bit. So what we're going to do is we're going to drop a line from the highest point and bring it down. And we are going to find the height of this triangle by using the supplementary angle to this straight angle. So if this is 150 this straight angle here is 180, that means this is 30. This is a right angle. So this is 30 degrees. And we know that we have a hypotenuse here that is 14 meters. So we can do this. We can find the sine of 30 degrees. And the hypotenuse is 14. And that is going to equal our height. So our height would be 14 times the sine of 30 degrees. So that would be 7 meters is the height. So now we have a height and we have a base. So 7 meters times 6 meters divided by 2 is going to equal 21 meters square. That is the area of this triangle. All right, so let us look at 56.3. Another example for you to go off of. So now we need to find the area of this trapezoid. So we know that in order to find the area of a trapezoid, so the area of this trapezoid is going to be base 1 plus base 2 times the height divided by 2. So that is what we are going to do. We are going to find the height. We have base 1, we have base 2, but we need to find the height. So what we're going to do is we're just going to draw a little line right here, making a right angle line perpendicular to the base here. And we have a hypotenuse and we have a degree of measure. So all we need to do is say 5 times the sine of 29 degrees is equal to the height. And here's the height. And 5 times the sine of 29 is going to equal 2.42 is the height. And that is going to be in meters. So now we can say base 1 plus base 2, that's going to be 14 meters times 2.42 meters divided by 2. And that's going to give us 16.94 meters square. So it's just another way to look at it, another way to find the height of a triangle when it's not given to you, or the height of a trapezoid. All right, not so hard. So that is 56 section A. There's some practice problems for you to do right after this. And then we'll move on to areas of segments.